No, there's just water in it.
Is it on?
Well, as Mrs. Surley promised, I'm going to share something with you that's more of a passion than a hobby for me, and that's making guitars, and talk a little bit about some mathematics relative to the guitars and music. Now, we have, I know for sure, one guitar player. How many guitar players do we have in the room?
Actually, I just picked it up for
How
it.
many string instrument players do we have? Violin, cello,
Ukulele.
ukulele. These stringed
Wait, I
instruments.
have a question.
Yes. No, I don't really know. But you do have to have an exercise for you to complete. That's what I handed out. You can complete it in the classroom, or you can hand it in tomorrow. But we'll get to that in a couple of seconds. Any general questions you want to start off with? Great. So we're going to talk a little bit about pitch or frequency as it relates to a guitar, tuning a guitar using a piano, how it relates to an exponential function, which we've been working on for the last week or so in class, and then a little exercise that includes the worksheet of how to tune a guitar, and then we'll go into a separate presentation on how to make a guitar, and if we have time left, I'll play a tune, or Oliver will play a tune on my guitar. Does that sound like a good deal?
Absolutely.
Okay. Is this better with or without light? You tell me. Without. Without? Okay. Pitch equals frequency, or the vibration of a string makes the sound, frequency. If you turn to page 335 of your textbooks, did you bring your books?
Yes.
Those of you that you want to look on. But if you turn to that page and look at problem number 35, you see a picture of a piano keyboard. You already see there? And what that graphically depicts is the range of notes that are available on the guitar versus a piano. And it doesn't look like it takes up the whole piano range, does it, from the picture? Now, tuning, frequency. Frequency is based upon tuning to concert A. And concert A on the piano is, if you look at your handout under where it says standard 6-string tuning, right here is concert A at 440 hertz. Now, this formula right here, 440 times 2 to the n over 12 power, represents how you can calculate the frequency of any note on the piano and the guitar as well, as it relates to how many steps away we move from concert A. So, for example, if we start at concert A and we want to move to the E, which happens to be the value of the high string, another high string on the guitar, how many keys do we move? Let's count them together. Starting with G sharp. 1, 2, 3, 4, 5. 5. So to calculate the frequency of E, that particular E, you would substitute what for n into this formula? 5 or negative 5? Negative 5. I'm going down. I'm moving to a lower tone. So it would be negative 5. Can you do that on your calculator? Keystrokes would be 440 times per n 2 caret per n. What do we have? Negative 5? Negative 5 divided by 12. Close per n, close per n. Anybody do the calculation?
29.
Has anybody done it? What did you get, Olive?
329.62.
That is correct. So the frequency of E, an E string, is 329.62 hertz. That is the sequence of the string vibration. Now, using that methodology, if you turn to the back of the sheet, here's what I'd like you to do either now or tonight. I'm going to collect this tomorrow, definitely, to calculate the values of B, G, D, A, an octave away from that A, and that E, below E, which correspond to the strings. We already did high E. We came out with 329.62 hertz. Make sense?
Yep.
Some things, interesting things to point out with the guitar relative to the piano. Middle C is this key. To me, I think of it as the key that faces to my right in the middle of the keyboard, where they have two white keys together, like that. You can find it on an 88 key piano keyboard pretty easily. But middle C on a guitar is actually, if I hold down my finger on the second string, the second highest string on top of the second fret, or the first fret, I'm sorry, that's middle C. So going up, let's talk about concert A. This A. A is right here on the high string above the 5th fret. So it doesn't look like I have too many notes to go, does it, if I move up on the guitar? I'm like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I really can't reach those. So I've got like 13 notes above concert A. If I try to play piano music as guitar music. So guitar is one of those instruments. How many play brass instruments like sax or you got B flat, E flat instruments? Yeah. It's a transposing instrument as well. So you have to read music written for sax, basically. And I play with the sax player. We're always transposing keys. So essentially, the guitar is what's called a C instrument, but it's like a piano. Only we have to, when we read piano music, instead of using middle C where this C is, this is a neck. This is the top of the neck. These notes here at the end are the note values of the open strings. So this is low string, that's my high string. This is middle C on the piano. When I read piano music, I have to use a different C. I put middle C over here, and I use that C in the blue group as middle C when I read piano music to play with the piano, play melody on the treble scale with the piano player. That's probably neither here nor there with some of you, but that's one of those oddities that happens with musical instruments. Any questions at this point? So going back to the formula for frequency, what was that again? 440, or call F of N, times 2, n divided by 12. What kind of function is that? Exponential function. What would be my A value? 440, that would be A. My B, 2, and there's my X, my variable. So someone in, I think it was Jacob Petrie, actually plotted the graph of this function, and he used the plot of the graph itself. He went to the table to determine the frequencies of these strings. essentially. Interesting. Any other questions? Yeah? We'll move on. We just went through that, right? Interesting note. Who's heard of Pythagoras? Pythagorean theorem, right? Yeah, he's kind of a weird dude. He lived about 2,500 years ago. He's credited with what? What's the formula? A squared plus B squared equals C squared. He actually did not discover that relationship. It's been, it goes back about 3,000 years to the Babylonians. There was a tablet that was discovered that had squares laid out a la the Pythagorean theorem. A's, B's, and C's. So think about the pyramids and how they were built and things of that nature. Yeah, people had to be aware of the Pythagorean theorem, but he's given credit with formalizing the process. He spent most of his life just taking measurements of things and measuring out squares of things. He was a Greek, born in Greece, lived and died in Italy. For a while he lived in Alexandria as well, in Egypt. But while he was living in Italy, he was kind of a hippie of his days. He was a strict vegetarian, and he had a cult, if you want to call them, or a sect of followers called the Pythagoreans. And they believed that the universe could be defined purely in terms of ratios. And what he discovered was, well, what he observed was that, look at this instrument. What you see here is a stringed instrument with strings that are blocked in two places. And these little things right here, guess what those are? Weights. They're weights. The heavier the weight, the higher the tension on the string. So he observed that, gee, just by pulling on the string, I make the tone higher, right? The pitch gets higher. First observation. Second observation, gee, there is certain ratios that I can define here. If I take the length of that string, that vibrating string, and pluck it without holding down anything, I get a note. The distance from here, which is called the nut, to the bridge. In this case, this guitar is a 25-inch scale, so this is 25 inches from here to here. 12th fret is always exactly halfway. It cuts the string in half. What do you get when you cut a string in half? Guess all. An octave. You get an octave. You get E again, only it's 12 notes up. So he observed that phenomenon, and from that he developed some weird scales, musical scales. Today we use a, how many note scale? Well, it's 12 notes. 12 note scales with sharps and flats in between. And what's the major scale we use in Western music? Do, re, mi, so, fa, la, ti, do. We only use 8 of them. Music and everything in between. It's like color tones. But at any rate, that's how we arrive at a guitar. Because the Greeks are taking credit for inventing this thing called the monochord, developed about 500 years before Christ, around the time of Pythagoras. And it is a simple musical device where you have a string stretched across 2 points, anchored here with some kind of tuning mechanism. And they used like abalone or something very hard to block the vibrating half of the string to get different tones. It's kind of like using a slide on the guitar. So that's the first act, so to speak. All right, any questions?
Do you have any idea what the Greeks would have made their strings out of? I imagine it wouldn't have been steel.
Animal gut.
Animal gut?
Yeah.